We look up at the night sky, countless stars twinkle above us. Each star is a sun, possibly with its own planets. The vastness of space is humbling, yet it also fills us with a sense of wonder. We long to explore the cosmos, to uncover its secrets. This drive to explore is deeply rooted within us. It is what led our ancestors to cross oceans and continents. Now it compels us to reach for the stars. Space exploration is more than just a scientific endeavor. It is a testament to the human spirit. It represents our desire to push the boundaries of knowledge and to discover new worlds. We dream of one day colonizing other planets, ensuring the survival of our species. But the challenges of space travel are immense. Distances are vast, environments are harsh, and resources are scarce. Overcoming these obstacles will require ingenuity, collaboration, and a relentless pursuit of innovation. Our journey into space has just begun. Mercury, a tiny world of iron and rock, orbits the sun at a blistering pace. Its surface is a desolate landscape. Craters scar the planet, remnants of a violent past. Temperatures fluctuate wildly. Days are scorching hot, reaching over 800 degrees Fahrenheit. Nights are frigid, plummeting to hundreds of degrees below zero. This extreme environment is due to Mercury's proximity to the sun and its lack of a substantial atmosphere. Despite these challenges, Mercury holds potential. Beneath its harsh exterior lies a wealth of resources. Mercury is rich in heavy metals, including iron, nickel, and potentially even rare earth elements. These resources could be invaluable for future space exploration and development. The idea of terraforming has captivated scientists and science fiction writers for decades. Imagine transforming a barren, hostile planet into a lush, Earth-like world. This is the dream of terraforming. It is a vision of humans shaping the solar system to meet our needs. But how do we turn this dream into reality? Terraforming a planet is a multi-stage process. It involves altering a planet's atmosphere, temperature, and surface to make it suitable for life as we know it. This is not a quick fix. Terraforming Mercury would be like giving the planet a complete makeover. We're talking about altering fundamental aspects of its environment. This is not simply landscaping, it's planetary engineering on a grand scale. But with each step, Mercury would inch closer to becoming a habitable world. Creating a magnetic field is crucial for protecting life from harmful radiation. One proposed method involves building a massive superconducting ring around Mercury's equator. The terraforming of Mercury is a long-term goal, a project for generations to come. But imagine the possibilities if we succeed. A terraformed Mercury could become a new home for humanity. It could be a hub for space exploration, a source of valuable resources, and a testament to human ingenuity. Imagine cities rising from the once barren landscape surrounded by lush vegetation. Picture vast oceans teeming with life, reflecting the light of a distant sun. This is the promise of a terraformed Mercury. A vision of a future where humanity has expanded its reach beyond Earth. The challenges of terraforming Mercury are immense, but so are the potential rewards. Mercury, the smallest planet in our solar system, is a world of stark contrasts and surprising secrets. Unlike its rocky siblings, Venus, Earth, and Mars, Mercury harbors a massive iron core, making up a staggering 80% of its volume. Imagine a planet where the ground beneath your feet is essentially a giant ball of iron, a cosmic magnet suspended in the vastness of space. This iron heart dictates much of Mercury's character, influencing its gravity, its interaction with the sun, and even its very shape. The immense density of Mercury's core has fascinated scientists for decades, raising questions about the planet's formation and its turbulent early history. Some theories suggest that Mercury was once a much larger planet, perhaps even twice its current size. A cataclysmic collision with another celestial body may have ripped away much of its outer layers, leaving behind the dense, iron-rich core we see today. Understanding the origins of Mercury's iron heart provides valuable clues about the formation of our own planet and the evolution of planetary systems throughout the cosmos. Time on Mercury unfolds in a manner that defies our earthly experience. A single day on Mercury, measured from sunrise to sunrise, lasts a mind-boggling 176 Earth days. Imagine a world where the sun crawls across the sky, taking its sweet time to set, bathing the landscape in perpetual daylight for months on end. This prolonged day is a consequence of Mercury's slow rotation, a languid spin that belies its rapid orbit around the sun. As if this weren't strange enough, Mercury's year is even more peculiar. It completes a full orbit around the sun in just 88 Earth days. This means that a year on Mercury is actually shorter than a single Mercurian day. This bizarre temporal dance has profound effects on Mercury's surface, creating extreme temperature swings that dwarf anything experienced on Earth. Mercury, the closest planet to our Sun, holds the dubious distinction of experiencing the most extreme temperature swings in our solar system. Unburdened by a substantial atmosphere to regulate its temperature, Mercury bakes and freezes in extremes that defy imagination. During its long, drawn-out day, the sun's scorching rays beat down on the surface, sending temperatures soaring to a staggering 800 degrees Fahrenheit, hot enough to melt lead. But as the sun dips below the horizon and darkness descends, Mercury's surface surrenders its heat to the frigid vacuum of space. With no atmospheric blanket to trap warmth, temperatures plummet precipitously, reaching a bone-chilling -290 degrees Fahrenheit. This dramatic temperature swing of over 1,000 degrees Fahrenheit in a single Mercurian day creates a hostile and unforgiving environment. The extreme temperatures on Mercury pose a formidable challenge to any future exploration or terraforming efforts. Unlike Earth, cloaked in its protective atmosphere, Mercury stands exposed and vulnerable in the face of the sun's relentless onslaught. Billions of years ago, Mercury may have possessed a tenuous atmosphere, a thin veil of gases clinging to its surface. But the sun's intense radiation and the planet's weak gravitational pull conspired to strip away this protective layer, leaving behind a desolate, airless world. Without an atmosphere to scatter sunlight, the sky above Mercury remains a perpetual inky black, even during the day. Stars would be visible at all times, their light undimmed by atmospheric interference. The sun, a blazing orb dominating the sky, would cast harsh, unfiltered light on the barren landscape. This lack of atmosphere also means that Mercury is bombarded by micrometeoroids, tiny particles of cosmic debris that constantly rain down on its surface. The absence of an atmosphere leaves Mercury exposed to the raw power of space, a stark and unforgiving environment that poses significant challenges to any future exploration or attempts at terraforming. Mercury's close proximity to the Sun, a mere 36 million miles away, subjects the planet to a constant barrage of solar radiation, a torrent of energy that shapes its environment and poses significant challenges to exploration. The Sun, a giant ball of superheated plasma, constantly emits a stream of charged particles known as the solar wind. This wind, a constant outflow of protons, electrons, and other particles, travels at speeds of hundreds of miles per second, carrying with it the Sun's magnetic field. On Earth, our planet's magnetic field acts as a shield, deflecting most of the solar wind and protecting us from its harmful effects. But Mercury, with its weak magnetic field, is less fortunate. The solar wind slams into Mercury's surface with full force, stripping away any trace of an atmosphere and bombarding the planet with radiation. This constant bombardment of solar radiation has profound effects on Mercury's surface. Understanding and mitigating the effects of this radiation is crucial for any future exploration or terraforming efforts. Beyond the constant bombardment of the solar wind, Mercury faces another, more sporadic threat from the sun's solar storms. These violent eruptions on the sun's surface unleash massive bursts of energy and charged particles into space, creating a shockwave that can reach Earth and beyond. For Mercury, unprotected by a substantial magnetic field, solar storms are a particularly daunting threat. The planet is directly in the line of fire, facing the full brunt of these solar tantrums. When a solar storm erupts, Mercury is bathed in a torrent of high-energy particles, a cosmic deluge that can have significant and lasting effects on its environment. These solar storms can further erode Mercury's already tenuous exosphere, stripping away any trace of an atmosphere. And for any future human explorers, solar storms would pose a significant radiation hazard, requiring advanced warning systems and hardened shelters to protect against these unpredictable events. Mercury's vulnerability to solar storms highlights the challenges of exploring and potentially terraforming a world so close to our turbulent star. Terraforming Mercury is not for the faint of heart. It is a challenge of unprecedented scale and complexity, pushing the boundaries of science, engineering, and human ingenuity. The planet's harsh environment, characterized by extreme temperatures, intense radiation, and a lack of atmosphere, presents a formidable obstacle course for even the most ambitious terraforming plans. Imagine attempting to tame a wild beast, a planet that seems determined to resist any attempts at transformation. Yet, the human spirit, driven by curiosity and a thirst for exploration, is not easily deterred. The challenges of terraforming Mercury are immense, but so are the potential rewards. Overcoming these challenges will require a multi-generational effort, a sustained commitment of resources, and the development of groundbreaking technologies. We will need to harness the power of the sun while also shielding ourselves from its wrath. We will need to engineer atmospheres, create magnetic fields, and find ways to regulate temperatures on a planetary scale. The terraforming of Mercury is a daunting task, but it is not an impossible one. It is a testament to the boundless potential of human ambition and our drive to explore and shape the cosmos around us. Before we can dream of transforming Mercury into a habitable world, we must first tame its fiery heart, the sun. Mercury's proximity to our star offers solar energy, but also presents a significant challenge. The sun's intense radiation bakes the planet's surface. Imagine cultivating a garden in a furnace. We need to regulate solar radiation. One solution is deploying massive sunshades in space. These would act like giant umbrellas, cooling the planet. By adjusting these sunshades, we control solar energy. The potential reward? A cooler, more temperate Mercury. Section 2. A magnetic shield for a tiny world. Mercury lacks a robust magnetic field, leaving it vulnerable to the sun's solar wind. This solar wind can strip away a planet's atmosphere over time. To make Mercury habitable, we need a magnetic shield to deflect the solar wind. Imagine a tiny boat caught in a hurricane. That's Mercury without a magnetic field. One proposal involves creating an artificial magnetosphere with satellites. These satellites would generate a magnetic field, deflecting the solar wind. This artificial magnetosphere would shield Mercury, allowing it to hold its atmosphere. Section 3. Conjuring an atmosphere from cosmic dust. With the sun's heat regulated and a magnetic shield in place, the next monumental task in terraforming Mercury is to give it something it desperately needs: an atmosphere. This life-giving blanket of gases is crucial for regulating temperature, shielding the surface from harmful radiation, and ultimately, allowing for liquid water to exist. But where do you find enough air to cloak an entire planet? Imagine trying to inflate a hot air balloon with a bicycle pump. That's the scale of the challenge we face in creating an atmosphere for Mercury. We need to find a source of gases vast enough to envelop an entire planet. One intriguing possibility is to look to the cosmos itself. Asteroids, those rocky remnants from the early solar system, often contain significant amounts of volatile compounds, substances that easily evaporate into gases. By carefully redirecting icy asteroids towards Mercury, we could use their impacts to release these volatiles, gradually building up the planet's atmosphere over time. This cosmic billiards game would require precise calculations and careful planning, ensuring that the asteroid impacts are controlled and contribute to the growing atmosphere without causing undue harm to the planet's surface. It's a delicate dance, but one that could ultimately provide Mercury with the breath of life. Section 4. The alchemy of air-breathing life into Mercury. Creating an atmosphere is only the first step. To make Mercury truly habitable for humans, we need to transform its composition, creating a breathable mix of gases that can support life as we know it. This means converting the initial volatile-rich atmosphere into one dominated by nitrogen and oxygen. the life-sustaining gases that make up Earth's atmosphere. Imagine trying to bake a cake with the wrong ingredients. You might end up with something edible, but it won't be quite right. Creating a breathable atmosphere for Mercury requires a similar level of precision, ensuring the right mix of gases for life to thrive. This is where the power of synthetic biology comes into play. Scientists are exploring the possibility of using genetically engineered microorganisms, specifically tailored for Mercury's environment, to convert the planet's initial atmosphere into a breathable one. These microscopic engineers could convert carbon dioxide, a likely abundant gas in the early atmosphere, into oxygen through photosynthesis, gradually transforming the air into a life-sustaining mix. This process, known as bioengineering, could take centuries to complete, but it offers a sustainable and elegant solution for creating a breathable atmosphere on Mercury. These microscopic life forms would become the planet's first inhabitants, paving the way for more complex life to follow. The quest for thermal equilibrium. Regulating Mercury's extreme temperature swings is an ongoing challenge. The planet's slow rotation creates a dramatic temperature difference. Imagine living where temperatures swing from oven hot to freezing cold. We need to stabilize Mercury's climate. One solution is to go underground. Building habitats beneath Mercury's surface provides natural insulation. Subterranean cities could be connected to the surface via tunnels. Another approach involves positioning large-scale reflectors in space. Orbital mirrors would act like giant heat sinks. Achieving thermal equilibrium requires innovative engineering and resource management. Section 5. The gift of water, the promise of life. Water, the elixir of life, is conspicuously absent on Mercury's scorched surface. This essential ingredient for life as we know it is locked away as ice in permanently shadowed craters at the planet's poles, hidden from the sun's relentless heat. To transform Mercury into a verdant oasis, we need to unlock this precious resource and unleash its life-giving potential. Imagine a desert transformed by a single, life-giving rainstorm. That's the transformative power of water on a planetary scale. Releasing Mercury's trapped water ice could jumpstart the process of terraforming, creating lakes, oceans, and ultimately, a more Earth-like environment. One approach involves using carefully controlled explosions or focused solar energy to vaporize the ice, releasing it into the atmosphere as water vapor. This water vapor would then condense and fall as rain, gradually filling up low-lying areas and creating bodies of water. Another possibility is to build a network of pipelines and pumping stations, transporting the water ice from the poles to other regions of the planet. This would require significant infrastructure development, but it would allow for more controlled and targeted water distribution. Introducing water to Mercury's surface would be a monumental achievement, marking a turning point in the terraforming process. It would lay the foundation for the development of ecosystems, the emergence of life, and ultimately, the transformation of Mercury into a vibrant and habitable world. Section 6. From barren rock to verdant oasis. A distant dream. Terraforming Mercury is not a short-term project. It is a multi-generational endeavor, a testament to human ambition and our enduring fascination with shaping the world around us. The challenges are immense, requiring groundbreaking technologies, unwavering dedication, and a deep understanding of planetary science. Imagine future generations looking up at a transformed Mercury, no longer a barren rock but a verdant oasis, a testament to the power of human ingenuity and perseverance. This is the dream that fuels our exploration of the cosmos, the belief that we can shape our destiny among the stars. The journey from barren rock to verdant oasis will be fraught with challenges and setbacks. But with each hurdle overcome, with each technological leap forward, we inch closer to realizing this ambitious vision. The terraforming of Mercury is a testament to the boundless potential of human ingenuity and our enduring quest to explore and shape the universe around us. It is a journey that will test our limits, inspire new discoveries, and ultimately redefine our place in the cosmos. The dream of a terraformed Mercury is a beacon, guiding us towards a future where humanity's reach extends beyond the confines of our home planet. It is a future worth striving for, a future where we become architects of our own destiny among the stars. seeds of life establishing ecosystems on Mercury. Transforming Mercury from a barren, sun-baked rock into a vibrant, life-sustaining world requires more than just air and water. It demands the delicate and intricate dance of ecosystems, where diverse life forms interact to create a self-sustaining web of interdependence. This means seeding the planet with life, carefully selecting and introducing organisms that can thrive in Mercury's unique environment, and lay the foundation for a thriving biosphere. Imagine a painter meticulously applying brushstrokes to a canvas, each stroke adding depth and complexity to the emerging image. Establishing ecosystems on Mercury is a similarly meticulous process, requiring careful selection and introduction of life forms to create a harmonious and self-sustaining balance. The first pioneers on this new world will likely be microscopic, extremophile organisms, life forms that have evolved to survive in Earth's most extreme environments. These hardy microbes, adapted to scorching heat, intense radiation, and limited water availability, will play a crucial role in converting Mercury's raw materials into fertile ground for more complex life. These microbial pioneers will prepare the soil, enriching it with nutrients and creating a foundation for plant life to take root. The introduction of carefully selected plant species, chosen for their resilience and ability to thrive in Mercury's unique conditions, will mark a turning point in the terraforming process, transforming the barren landscape into a tapestry of green. The architecture of life designing Mercurian ecosystems. Building a functional ecosystem on Mercury is not simply a matter of scattering seeds and hoping for the best. It requires a deep understanding of ecological principles and the intricate relationships between different life forms. Scientists will need to act as ecological architects, carefully designing and constructing ecosystems that can thrive in Mercury's challenging environment. Imagine a conductor orchestrating a symphony, each instrument playing its part to create a harmonious whole. Designing Mercurian ecosystems requires similar orchestration, ensuring that different life forms interact in a way that supports the overall health and stability of the biosphere. This means considering factors such as nutrient cycles, energy flow, and predator-prey relationships. It involves selecting species that can tolerate Mercury's high levels of solar radiation, utilize its limited water resources efficiently, and contribute to the overall stability of the ecosystem. The creation of self-sustaining food webs is crucial. This might involve introducing insects and other invertebrates to pollinate plants and decompose organic matter, followed by small herbivores and omnivores to control plant populations and provide food for larger predators. This careful orchestration of life will require ongoing monitoring and adjustments as the ecosystem evolves and adapts to its new environment. It's a delicate dance, but one that holds the key to transforming Mercury into a thriving and biodiverse world. The dance of photosynthesis, energizing a new world. At the heart of any thriving ecosystem lies photosynthesis, the remarkable process by which plants and other organisms harness the energy of sunlight to convert carbon dioxide and water into sugars, releasing oxygen as a byproduct. This process is the engine that drives life on Earth, and it will play a pivotal role in energizing Mercury's nascent biosphere. Imagine a solar panel converting sunlight into electricity, powering homes and cities. Photosynthesis is nature's solar panel, converting sunlight into the chemical energy that fuels life. On Mercury, this process will be crucial for transforming a barren world into a vibrant ecosystem. The introduction of photosynthetic organisms, starting with hardy algae and bacteria, and eventually progressing to more complex plants, will be crucial for establishing a self-sustaining biosphere on Mercury. These organisms will capture sunlight, converting it into energy that fuels their growth and reproduction, while simultaneously releasing oxygen into the atmosphere, making it more breathable for other life forms. The success of photosynthesis on Mercury will depend on several factors, including the availability of sunlight, water, and essential nutrients. Scientists will need to carefully select plant species that can tolerate the planet's high levels of solar radiation and utilize its limited water resources efficiently. As photosynthetic organisms spread and thrive on Mercury, they will transform the planet's atmosphere, enriching it with oxygen and paving the way for more complex life forms to evolve and flourish. Introducing life to Mercury starts with the hardiest microorganisms, Gradually, more complex life forms will follow as the environment becomes hospitable. Imagine a ladder, each rung representing a different level of ecological complexity. Starting with the simplest organisms, we ascend to more complex life forms. Extremophile microorganisms will prepare the planet, enriching the soil and cycling nutrients. As conditions improve, hardy plants, insects, and invertebrates will be introduced. Eventually, small vertebrates like fish and amphibians will follow, carefully monitored. Over time, the possibility of introducing larger animals, even mammals, becomes real. Fostering biodiversity on a new world. A truly habitable planet is a complex and interconnected web of life. Fostering biodiversity on Mercury is crucial for a stable and resilient biosphere. Imagine a tapestry woven from countless threads, each representing a different species. This includes plants, animals, fungi, bacteria, and other microorganisms. Ongoing monitoring and management will maintain a healthy balance of life. The rise of complexity on Mercury will be a testament to human ingenuity. Section 7. Sheltering humanity. Building habitable spaces on Mercury. While transforming Mercury into a verdant, life-sustaining world is a long-term goal, establishing a human presence on the planet will require creating safe and habitable spaces that can shield inhabitants from the planet's harsh conditions. This means designing structures that can withstand extreme temperatures, intense solar radiation, and the constant bombardment of micrometeoroids. Imagine a seed buried beneath the soil, protected from the elements while it germinates and grows. Early human habitats on Mercury will need to provide similar protection, shielding inhabitants from the harsh realities of the planet's surface while life takes root and flourishes. Underground habitats, nestled beneath the planet's surface, offer a natural shield against radiation and temperature extremes. These subterranean cities could be connected to the surface via networks of tunnels and airlocks, allowing inhabitants to access resources and explore the surrounding landscape. Another option involves constructing surface habitats with advanced radiation shielding and temperature control systems. These structures, perhaps partially buried or covered with a layer of regolith or lunar soil for added protection, could be designed to mimic Earth-like conditions with controlled atmospheres, artificial gravity, and even simulated day-night cycles. As terraforming progresses and Mercury's environment becomes more hospitable, these early habitats can expand and evolve, eventually merging with the surrounding ecosystems to create a seamless integration of human life and the natural world. Section 8. A new home among the stars. The future of human life on Mercury. Terraforming Mercury is a multi-generational endeavor, a testament to human ambition. It is fraught with challenges but brimming with possibilities. Imagine children on Mercury gazing at familiar constellations. This dream fuels our exploration of the cosmos. A terraformed Mercury could become a hub of human activity. Its proximity to the sun offers immense potential for solar energy. A successfully terraformed Mercury would represent a profound shift in our relationship with the universe. It would be a testament to human ingenuity and our quest to explore. The journey to terraform Mercury will be long, but the rewards make it worth undertaking. Section 9. A Mercurial Future. The journey towards terraforming Mercury is not a sprint. It's a multi-generational marathon. We are laying the first bricks on a path that might take centuries to pave. Yet the very act of imagining such a future speaks volumes about the human spirit. We are a species that strives, that dreams, that refuses to be confined by limitations. Picture this. Centuries from now, Mercury is no longer the scorched, barren world we know today. Instead, it thrives with life, a testament to human ingenuity. Domed cities shimmer under a carefully calibrated sunshade, while engineered ecosystems flourish across the surface. Water, once trapped as ice, now flows freely in canals and man-made lakes reflecting the starlight. This mercurial future wouldn't just be a victory of science and engineering, but a victory of the human spirit. It would signify our evolution from passive inhabitants of a single planet to active shapers of our cosmic environment. The challenges are monumental, requiring advancements in fields from materials science to bioengineering. But overcoming these obstacles, one by one, is what pushes humanity forward. The terraforming of Mercury is not just about creating a new home, it's about pushing the boundaries of what's possible. It's about proving that we can face seemingly insurmountable challenges and emerge victorious. It's about securing a future for humanity among the stars. Section 10. The larger tapestry of exploration. Terraforming Mercury is not an isolated ambition. It is a thread in the larger, intricate tapestry of space exploration. Each mission we undertake, each probe we send into the cosmos, each experiment conducted on the International Space Station adds to our knowledge. This accumulated knowledge, like pieces of a giant jigsaw puzzle, gradually reveals the bigger picture of our universe and our place within it. As we learn to manipulate environments on a planetary scale, as we unlock the secrets of closed-loop ecosystems and master the art of resource management in the vastness of space, we gain invaluable insights. These insights will not only aid our efforts on Mercury, but will also inform our approach to challenges on Earth. Imagine applying the solutions developed for radiation shielding on Mercury to protect communities living near nuclear power plants. Picture the advancements in closed-loop agriculture designed for Martian colonies revolutionizing food production in arid regions here on Earth. The knowledge gained from terraforming Mercury could have a ripple effect, leading to innovations that benefit all of humanity. The quest to terraform Mercury is a driving force for innovation, pushing the boundaries of science and technology. It is an investment in our future, not just as a spacefaring species, but as caretakers of our own planet. Section 11. Humanity, a multiplanetary species. The prospect of terraforming Mercury begs a fundamental question. What does it mean to be human in a multiplanetary age? As we venture beyond Earth, we carry our values, dreams, and responsibilities. Mercury will be a new branch in human civilization, shaped by its unique challenges. The journey to terraform Mercury is about discovering what it means to be human.